Like all transportation systems, like your car, your boat, a plane, the more your rocket has the capability of going further, the bigger it will be. A rocket that has the capability of going to Earth orbit will be much more smaller than a rocket that will put humanity on Mars. That seems logic, but how do we classify them? For that, I need to introduce you to a unit of measure called delta V. Consider that velocity of your rocket is an arrow. At the launch pad, that arrow equals to 0. But when the rocket lifts off, suddenly that arrow starts to change rapidly. And it's actually the change of velocity of your rocket. It is measured in meters per second and defines your rocket tanks, your engine, and all components. Thanks to the holy grail of rocketry, the rocket equation. It says that the delta V is equal to the velocity of which the gas are expelled from your rocket times the Neperian logarithm of the ratio between the mass of your rocket with fuel and the mass of the rocket without fuel. If you know the delta V of your rocket and the specific of the rocket engine, you can figure out how much fuel you need. The greater the delta V, the more velocity you can change, and therefore you can change trajectory. Now that we know delta V, let's make a classification of rockets. Let's go! Our journey through rocketry starts here, with model rockets. Did you ever saw an ad for little rockets made out of baking powder and Coca-Cola? Those are capable of going to 20 meters of altitude. You will say he has no correlation with space industry whatsoever. If you thought that, you are wrong. Because that's where everybody starts. And that's where I started. It's the beginning and the catalyzer for a new passion. Because no matter the size of a rocket, the adrenaline that you will feel when they lift off is always the same. Model rocket is what we consider to be low and mid power rocketry. But what's next? High power rocketry. And oh boy, I love this category. Because you can literally make a rocket that goes to 5 kilometers of altitude by scratch and by yourself in your bedroom. Just like I did. But to be able to launch those rockets, you need to pass some exam. What do I mean by exam? There's an organization called Tripoli Association of Rocket that supervises all the launch of high-power rocketry in the world. Tripoli recognizes 3 levels, and in order to pass a level, you have to launch a rocket bigger each time and bring it back home safely. The rocket must be able to be launched again immediately after its landing. Otherwise, you don't get the certification. Let me show you what an HPR rocket launch looks like. Now, we arrive to a point where making rocket by yourself is quite impossible. The next category of rocket is a huge gap from HPR rockets. I'm talking about the space shots. And you will tell me, what's the objective? Send a rocket of 2 or 3 meters high, just above space, and get it back. It can be done in the USA, even by some amateurs. Okay, it's another level of complexity. But I think it's just amazing that a group of friends can make a rocket and send it to space with just $20,000. While some buy a car, others construct a rocket to send it into space. Even GoPro has achieved the goal. You don't believe me? The next category of rockets is the same principle of the last one, just with a bigger budget and with the capability of carrying an astronaut. I'm talking about the industrial suborbital flights. A suborbital trajectory is when a rocket goes higher than 100 kilometers but doesn't go to orbit and comes back few minutes later. In the early days of space travel, the suborbital flights were used in the Mercury missions. They were used to see if an astronaut could be launched and recovered back in a space capsule. With the democratization of space travel and the development of space tourism, companies like Blue Origin and Virgin Galactic use suborbital flights to make their customers fly to space without having the problem to go to orbit. Although I think with a ticket costing $300,000, they could at least send people into orbit. But suborbital rockets are not only made for commercial flights, but also for research flights. For example, the crowd-funded company Copenhagen Suborbitals plans to send an astronaut to make a suborbital flight, just like Alan Shepard did in 1962. Suborbital rockets have usually two stages: the booster stage that sends all the rocket into space, and the space capsule for carrying the astronauts. Let's talk about the serious stuff now. The orbital rockets. There are a huge gap between suborbital and orbital flights. You will tell me, you are still in space. Yeah, but in order to go to suborbital trajectory, you need to accelerate to 1.6 kilometers per second. And to go to orbit, you need 8 kilometers per second. You need to accelerate 5 times more to go to orbit. And obviously, you will need more fuel, so a bigger rocket, and so a bigger budget. In rocketry, a payload is a mass that is not necessary to make the rocket works. It can be a satellite, a spacecraft, or some experiment. In orbital category, we can distinguish two types. The orbital rocket capable of sending a small payload into space, like the Vega rocket or the Electron rocket, designed to bring small satellite called nanosatellite to Earth orbit the size of a ball. And then you have the orbital rockets that can bring a huge amount of payload into orbit. In this category, we also put all the manned mission to space. SpaceX has the most reliable and efficient rocket for this kind of mission, the Falcon 9. It can send a stunning 23 tons to orbit. That's at least 12 Tesla Model S cars. The Space Shuttle was also a monstrous rocket for large payloads. It could bring 24.5 tons into orbit and be the home for 8 astronauts for more than 2 weeks. But those are small rockets compared to the next category of space launches. You see, on a cosmic scale, the planets and the moon are very far from Earth. Just to go to the moon, if we take a normal commercial airplane going at 900 kilometers per hour, it will take 18 days to just go to the moon. Can you guess how much it will take with a normal plane to go to Mars from the Earth? 7 years with a commercial flight traveling at 900 kilometers per hour. That's a difference, right? If you just imagine the fuel you need to leave Earth, it's amazing. And you have a rocket like the SLS from NASA with a height of 100 meters. However, the technology needed to send humanity to Mars is not yet discovered. There's a lot of problems that has to be solved. How the spacecraft will deflect radiation from the sun, or how astronauts are going to live on Mars. Lots of problematic that will define the next generation of rockets, capable of sending humanity to the solar system. And it's happening now and in the next decade.